Hey there, and welcome to How To Videos with Dr. Amy Gates. This video is going to show you how to find the correlation between two variables, or the R value. It's also going to show you how to create a scatter plot, and then how to use that scatter plot to generate the linear regression equation that you can use then to predict one of your variables if you have the value of the other. So let's get started. This is just a make-believe data set. It's completely fictitious. It has the person's ID, their age, their weight, their GPA, their gender, and the number of hours they spend studying every week. So let's find out if initially there's a correlation between age and weight. Again, this is fictitious data, so I've created these numbers in order to show certain correlation activities, but not to make a commentary on age and weight gain. So in order to find the correlation, you've got a couple of options. If you're new to Excel, the easiest option is to go up to More Functions, Statistical, and then look for Correl. Correl stands for correlation, and if you choose Correl, it'll ask you which two columns or array of data, in other words, which two variables are you wondering what the correlation is between. So you have a couple of choices here as well. You can use your mouse to select the data. So I can use my mouse, I can press the left mouse button down, collect all the data until it's encircled, and then release it. And by doing that, I automatically selected B2, that's my starting point here, and all the way down to B11, and that's the last piece of data. And you can also just type this in by hand. So if I type next to the other array or column of data, that's going to be the weight, because I'm looking for age and weight. So weight data is located in C2 all the way down to C11. Be careful not to include C1. C1 is not part of your data set, and if you include it accidentally, it will create an error for you. So in this case, I've got C2 colon, because I want to go all the way through to C11. That's where the second column of data is for my weight variable. Now if I click OK, I find out that my correlation between age and weight is 0.789 and change. That's very high. So that's an extremely strong positive correlation. So for this particular small data set, I can claim that my R value, which I'll type over here so we remember what we're doing, the R value, or the correlation between age and weight, is both strong and positive. Now, one of the things that's true if you have a strong correlation, either a strong positive correlation or a strong inverse or negative correlation, you can then use regression, linear regression, to do some prediction. So if I know someone's age, but their age isn't actually here, I can predict their weight. It's not going to be exact because my correlation's not 100%, but it's going to be pretty close. So for example, I have the age of someone who's 23, I know their weight. I have the age of someone who's 21, I know their weight. 28, I know their weight. I've got a really good correlation between age and weight. So if someone comes along who's 22 years old, I don't have their age here, but if I have an equation that describes the relationship between age and weight, I can plug in their age of 22, and I can calculate an estimate of their weight. So the way you do that in Excel is you first have to get the scatter plot and then the equation. So I want to create a scatter plot. Let me go ahead and click over here in a blank area before I get started. I always like to do that so Excel doesn't do anything weird. I'm going to create a scatter plot of this data. In other words, I want to scatter the age and the weight and compare them to each other. What's going to happen in a scatter plot is age is going to end up being my X variable, weight will be my Y variable. So someone who's 23 has a weight of 120, someone who's 28 has a weight of 135, and so on. These individual points will be plotted, and you'll see your scatter plot. So the way to make a scatter plot in Excel is you first you highlight your data, then you click on Insert, and then you come over here to the different chart options. Find the one that looks like a bunch of scatters everywhere, scatter plots. Click that arrow, and it'll start to give you some options. If you mouse over the options, a nice thing about Excel, it'll show you what you're going to get. Like, we don't want that one's messy. This is not what we're looking for at all. We're definitely just looking for a standard scatter plot. So I'm going to click OK there, and it's created the scatter plot for us, which I will attempt to move over to here so we can see it a little bit better. There we go. Alright, so along the base, along the x-axis, we've got our age, and up the y-axis we've got our weights. And we can see that the points between age and weight, so here's our person who's about 21 years old and weighs about 100 and maybe 5 or 8 pounds. That's this guy. This point is for the person who's maybe about 23 or 24 and they weigh 120. Let's find them. Here's them. So basically everybody's here, a dot for each one of these pairs of age, comma, weight. Now here's something cool. If I click on any one of these pairs, it'll highlight them all for me. The next step is to put your mouse over any one of them, and of course it'll show you the value if you do that, which is nice as well. But if you put your mouse over, you can right-click your mouse, and then you can add a trend line. A trend line is the linear regression analysis that Excel will do for you. It'll create the best line it can to fit all these points, kind of like an estimate line. And so here's the line, and it lets you, move it around if you want to, but it's giving you the best line that it can create. Over here to the side, and let me go ahead and shrink this a little bit so you can see it better, it opens up some options for us. We definitely want a linear line, so we're going to keep that. And if we scroll down a little bit, we have the option of displaying the equation of that line on the chart itself. And we want that because that equation is our prediction equation. It's our linear regression equation. So when I clicked that box, it created this equation for me, which I'll move up here. And I can even make it larger if I want to get a better look at it. So this equation here is your prediction equation. And it's from this line that is your best fit line for all of your points. The better your correlation, the better your prediction equation will be. Notice the x value in this equation. It's really important to keep track of which one of your variables is on the x-axis, in our case it's age, and which one of your variables is on the y-axis, and in this case it's weight. So if I plug in any age into this equation, I could calculate the weight. And vice versa. If I plug in a weight for y, I can calculate the age. If you mix up x and y, you can run into a problem. So you want to make sure you remember which one is which. And the best way is just look on your x-axis. This is where your age is, and this is where your weight is. So this tutorial explained how to create an R-value or correlation, how to produce a scatter plot, and how to then create a trend line, and from that the regression or prediction equation that you'll need to predict any age from any weight or vice versa. Thanks for joining me.